All right, guys, so today's going to be our second day on 5.3 function notation. We're just going to be building up on what we learned at the beginning of the week. Now, keep in mind that I said build up. If you did not watch the video in the first week, that is what you should be doing because, again, this is building on itself. If you don't have the right foundation, you're going to struggle a little bit. So, attempt 1 and 2, get your mindset into what is function notation. Remember what that notation is asking you to do. Remember, you are responsible for these entry tests, so make sure you complete them. Now, if you kind of forgot, I'm going to go over how to find an input-output pair, which is pretty much the same thing as above. So let's get to that first. Now, I know the directions ask you to find 2 input or output pairs, but for sake's time, we're only going to find 1 input and output pair. And it is our job to find that pair for the following and represent them as ordered pairs, a graph, a mapping diagram, and a table. So let's just start with talking about all the different representations. When I have an ordered pair, it's just parentheses with a comma in the middle where my x is listed first and my y is listed second, aka my domain is first or input, followed by my output or my y. When I have a graph, I'm going to have the x and y coordinates or vertices or axis. And then for my mapping diagram, I'm going to have my 2 ovals. And for my table, I'm going to have my x and y. Now, you got to make sure that you understand what you're doing here. There are infinite amount of options or pairs that you could find. It is your job just to find one of them. And the way you do that is just to choose an x. Choose whatever value you feel makes sense. I'd suggest using a number that's small, probably 0 to 5 max, so that way you don't have to deal with big numbers. I'm just going to choose a 5 because that's the first number that popped in my head. And you can choose anything you want. Choose whatever x value you want, and it is your job to find its output pair. Now, each x is going to have a different output pair. You just have to find it correctly. If you chose 3, it's going to be different. If you chose 2, or if you choose 5 to go along with me, it's going to be different. So let's go ahead and find that output pair. So remember the way that function notation is read. You have some function z. I think of it as a machine. And you're inputting whatever the x value is, or the input, which is a 5. And that's going to be equal to negative 2 times whatever x is. And remember our x that we input is a 5 squared minus whatever x is, which is my input of 5. So literally what I'm doing is just plugging in my value for x. Now, I am looking for z of 5. I'm looking for my function when my input is 5. It is equal to all that stuff. So now it's your job to find what all that stuff is. PEMDAS is always going to be your best friend, especially in this activity. So let's go ahead and make sure we write it down to memorize what it is. So there's no work to be done inside of these parentheses, but there is exponents right over here. That is 5 squared. 5 squared is a positive 25. That negative 2 was multiplied, so I'm going to put my dot there to make sure that I remember. Now, there was no parentheses, no more exponents after I got rid of those, and now I have multiplication or division. So there's 2 multiplications. Negative 2 times 25 is a negative 50. Technically, when I distribute, I am multiplying, so I'm going to distribute that through, and I end up with a negative 5. So after that, you'll notice that there's no multiplication or division. It's just really subtracting. Negative 50 minus 5 is a negative 55. So make sure that you are writing complete math statements. So I know sometimes because the left side doesn't change, you forget to write it down, but you have to, so that way you don't get dot points. So this is why function notation is a little useful, because it shows you an input, it shows you your output in a really quick notation. So how do I put that information in order pair? Well, this is my input, my output, what I got out is a negative 55. In terms of a graph, I would have an x of 1, 2, 3, 4, 5. Now I'm going to have a y of negative 55. Now remember that I am not going to expect you to write 55 dash marks going down. If you're in the white quadrant, somewhere down here in this area, I'm going to be fine with that. Now remember, when the mapping diagram, on the left is your domain values, on the right is your range values. And you have a mapping diagram or an arrow showing the relationship between 5 and negative 55, or showing that it's an ordered pair. And then finally, a table is just the x and the y opposite of each other. So that is exactly what we covered. For the most part, we covered a lot more of this material, but if you know that, the rest of it is kind of just knowing where to put things. So now that we reviewed that a little bit, let's go ahead and start working on building up a little bit, understanding what the notation is telling us to solve when. So I gave you a notation. C of x is equal to a negative 2x plus 1. I want you to find the following. C of negative 5, and then I want you to find C of x is equal to negative 5. Now you need to train your mind to understand what it's asking you. The way I learned this best is to think of it as an ordered pair. Because when you solve these two, they're two different problems. There's two different ways of solving. There's two different things that they're asking you to do, and you need to be able to recognize it. Remember that if you read this notation, you have a C function, which is right over here, and you're inputting a negative 5. Remember that your input is just the x value, so you're plugging in a negative 5 and solving for your range or your y value. So that is just practice. We've done this over and over again. So let me show you what that looks like again, so that way you can see it right next to what the difference is here. So you remember that you're inputting a negative 5. So here's my equation. I always like to write it, and everywhere there is an x, I like to leave open parentheses. Then I go back and I plug in whatever my input is into those parentheses, which is a negative 5. Now, C of negative 5 is what I'm looking for, so I'm going to use my PEMDAS on the right. Negative 2 times 5 is a positive 10. Almost said negative 10. And then you have your plus 1, which equals 11. So C of negative 5 equals 11. So when you have a C function and you input a negative 5, you'll get an 11 out. That is what you found. Now notice that the second one is a little bit different. It's not telling you what the input is. They're telling that your input is an x. But when you input that x into your C function, you are getting a negative 5, aka your output is a negative 5. So you can see here in this ordered pair what you're looking for. You're looking for your input when your output is a negative 5. So let's write an equation to figure out where in the world and how we're going to find that. Now remember that they told you what C of x equals. They told you what that whole C parentheses x. Here's a C parentheses x. It is equal to negative 5. That means that I know what that C of x equals. I'm literally erasing it right now and replacing it with what they told me it's equal to, which is a negative 5. And now you can clearly see what you got to do in order to find that x. You just need to solve for the x in the equation. Remember, when you solve for x, you want to get rid of everything else around it. So I'm going to get rid of that plus 1 by minusing 1 on both sides. You end up with a negative 6 is equal to a negative 2x. Dividing by negative 2, you end up with 3 is equal to x. So if I were to write this in ordered pair, my input would be a 3, and my output would be a negative 5. Again, train your mind that when you see your function equal to a value, they're telling you to set that whole function equal to that value and find the x that makes it true. Let's go ahead and just do a second example, because you're not going to get this the first time around, or if you're struggling, you'll notice that the more examples you do, the better you get at it. So again, I gave you a function g of x, and I gave you g of 4, and then I gave you g of x is equal to a negative 24. Those are two separate problems that you need to make sure you understand. Whenever I have an input, I write down my equation, and everywhere I have an x, I write open parentheses, and then I go back and plug in my input. Now remember, this is what they're telling me to find. This is what it's equal to. Using PEMDAS, there's no work inside the parentheses, no exponents, but there is multiplication. So I end up with negative 6. 3 times 4 is a positive 12. Adding those up, because that's the only operation left, would be a positive 6. So g of 4 is equal to a positive 6. You have now found what that equals. That equals a positive 6. Now, they told me what my function is equal to. G of x is the function. It is equal to 24. So if I have g of x is equal to negative 6 plus 3x, they told me what g of x equals. They told me what my function is equal to. It's equal to 24. So let's erase that g of x, because again, we know what it equals. It equals 24. And it is equal to all that function. Now it's just your job to solve for x. Remember that you get rid of everything that's getting added or subtracted, which is that negative 6. So I'm going to add 6 to both sides. You end up with 30 is equal to 3x. And finally, dividing by 3, 10 is equal to x. So pretty much the general idea, and I'm going to erase this, so make sure you press pause if you haven't finished writing that down, is that you're pretty much finding, one of them gives you the input and you find the output. The other one is giving you the output and you find the input. AKA, one gives you the x, solve for the y. One gives you the y, solve for the x. But you need to train your mind that when you see these, you understand which one is which. The easiest way to think of it, I like to, is like, okay, if they give me z, some function letter, and they give me a z, and here's my z function, of course, and I know my input, I know it's in those parentheses, that's the x. It's literally right here in my equation. Z of whatever x is going to be equal to a negative 1/2 times whatever x is plus 1. And then I input whatever the input is telling me to put, input, which is 0. Now, z of 0 is what I'm looking for. Solving for the right side, there's no work inside the parentheses. There's no exponents. There is multiplication. Now, negative 1/2 times 0 is anything times 0 is 0. So these technically become 0. You're going to add 1. Then 0 plus 1 is 1. So you found z of 0. You found the value of your function when x equals 0, which is a positive 1. If you were to put this in an ordered pair, you would end up with 0, 1. Now, this told me what my function equals. It tells me that my z of x function is equal to 3. So if this is my equation, negative 1/2 x plus 1, they are telling me what the whole function is equal to. This is what the whole machine, the function, equals. Z of x is equal to 3. You can erase it, you can just replace it. Doesn't matter as long as you get the general idea that that whole function is equal to 3, and then you're able to solve for it. Now, a lot of people are kind of scared of that fraction, but don't worry. Get rid of what you're adding and subtracting. Get rid of that 1. So I'm going to subtract 1 on both sides. End up with 2 is equal to a negative 1/2 x. Now, a fraction is scary, but remember, it's just division. This is a negative 1 divided by 2. What's the opposite of dividing by 2? Well, it's multiplying by 2. What I do to one side, I do to the other. These 2's cancel out. You're left with 4 is equal to a negative 1x. Finally, getting rid of that negative 1, you end up with a negative 4 is equal to x. So, you found the x value. If you go back to your original equation, z of negative 4 is equal to 3. What this is telling you is that when you input a negative 4 into your equation, you are going to get a 3 out. And that's pretty much it. If you could recognize the difference between those two, you're going to be miles ahead when we start building on this even more and we start using notation over and over.